ahead, and then I can hit start whenever you're ready. So I'm now in as a producer.
Okay, I'm hit continue.
Okay, you're started now.
Okay. We're all set.
You are live.
Good morning, everybody. Would you record this, Dan?
Yes, sir.
Good morning, everybody, and welcome to the Teams live event on managed PoE functions. Apologies for the late start. We had a couple of technical difficulties, some of them self-inflicted. But what we wanted to do is today we wanted to go through a couple of managed power over Ethernet functions that are very important. You know, the advent of power over Ethernet, it has crept into all areas of the industrial area, and has become a very important player. And basically, just you know, from an overview standpoint, power over Ethernet, it covers everything from the injector to the splitter, and that's what we like to classify it as. There's all kinds of devices that can be utilized in power over Ethernet. So if we take a quick look at the agenda that will follow today, first off, we're going to start off with power over Ethernet technology, discuss that a little bit. For anybody that may be on this session that is not too familiar with power over Ethernet, it gives you a brief overview of it, of the technology, and how it operates. Then we'll take a look at some important PoE applications, the things that are driving the surge in power over Ethernet usage in our areas. Then we're going to get right down to looking at three key managed PoE switch functions, and this is what separates it. This is what sets the managed functionality apart from injectors or unmanaged or any quote-unquote dumb devices that might be supplying power over Ethernet. And those are going to be the configuration area. And then we'll take a look at the PoE scheduling area. And then finally, my favorite function, the Watchdog. Finally, we'll close everything up by looking at a little demonstration that I've got put together here. So first, taking a brief look at PoE technology. PoE is made up of different device classifications. Mainly, you've got a PSE or power sourcing equipment, and then you've got PDs or powered devices. And the power sourcing equipment is responsible for sending that power and data to the end device. It's all done over the RJ45 cable in power over Ethernet, and that is how the devices receive their power. The PD on the other hand, is just defined as the device that receives the power on the other end. There's a number of different varieties of power delivery, and you know, we could have a whole separate session on just the nuance and intricacies of power over Ethernet. But suffice it to say that that PSEs will follow one chosen method of power delivery, while the PDs, by definition, should support all of them. If we take a look at the standards, this is the next thing to look at. We can see right away that by looking at the 8023AF standard, that power over Ethernet has been around for quite some time. There's a popular misconception that power over Ethernet has just been a recent development, but it has been around quite a while. Initially, it was started to take care of low power devices like IP telephone systems, wireless access points. And what it did is power over Ethernet represented a host of benefits to the end users. What they could do is they could move around wireless access points without without having to redo power in a different area. They could, by having IP telephones, they could move phones to different areas without having to install jacks. So this was done for a matter of convenience, and it was the beginning of bringing so many different things, so many different devices onto the Ethernet. The original standard was what we classify as the 15-watt standard. You'd have about 15 watts of power available at the port, and then you'd be just under 13 watts of power available at the end device, accounting for length of cable, taking care of that. It was also known as PoE or two-pair PoE because by virtue of power over Ethernet being utilizing only the two pairs in a potentially 8-conductor cable. In 2009, you can see that the AT standard upped the ante. We saw that basically the 30-watt standard with about 25 watts available at an end device. This was just classified as PoE plus, and this was because the PoE features, the standards, by having the standards, they spawned a lot of new technology, and the new technology spawned the need for more power, higher power demands, and the need for additional standards. This is where the AT standard is where we saw things like a step up from simple fixed cameras to utilizing pan, tilt, and zoom, higher definitions in the cameras, high power wireless systems, alarm systems, LED lighting systems. There was a lot more devices for PoE plus. Now, more recently, in 2018, the BT standard was ratified, and this really took it to a whole new level. So basically, there was two new types of PoE added to the mix, basically a 60-watt and a 90-watt mix with a minimum availability of 51 or 71 watts at the end device. Now they're using all four pairs for PoE with the BT standard. So some people call this PoE Ultra, PoE Plus Plus, whatever the case may be. It is high-powered PoE. Another thing to keep in mind with PoE is that compliant devices will negotiate the required power. There's nothing to define, no settings if you don't need to. There's no settings to set. And the other key thing to differentiate is that we've got their active PoE. All that we're talking about today is with active PoE. There is a passive PoE, which is a lower tech version of PoE. We're not going to go into that. This is all active PoE. So taking a look at some applications, what are the applications that really drive this? Well, the first one I want to look at is industrial automation. Industrial automation is always an early adopter of technology and new functionality. And where we're seeing this, or target PDs, the end devices in industrial automation, we're seeing a lot in vision systems. You've got vision inspection, you've got visual inventorying. A lot of vision systems are now utilizing power over Ethernet and driving the need in industrial automation. Again, wireless access points. As more and more networks go to wireless and have the need for more wireless access points, different types of access points, this is another area where that's exploding power over Ethernet. Additionally, we're seeing it in machines and robots. There's a lot of different devices that are now going towards Power over Ethernet, utilizing Power over Ethernet, and seeing the benefits, the lower cost of ownership with Power over Ethernet. The application drivers, of course, IIoT and Industry 4.0. The need for metadata. How do you get that metadata? You get that data by having the devices on the Ethernet network. And the best way to do that is to be able to power the device and have the signal going to the device all on one cable. This gives the rise to better factory analytics and everything that is associated with that. Machine learning. There's a need for transparency and coordination of operations inside and outside the factory. Everything from the product demand to production, forecasting, logistics, all can be assisted by Power over Ethernet. And then you get flexibility with modular manufacturing. If there are devices that are powered over the Ethernet cable, it makes it much easier in a modular setup to move items around, make changes, and be very flexible in your production system. Another one, and this is a biggie, security and surveillance. We're seeing more and more need for security and surveillance, whether it's inside surveillance or security, perimeter security, all different kinds of surveillance and security. There's the main target PDs in this are cameras, and what we're seeing here are the need for the high-powered Power over Ethernet in a lot of security and surveillance systems. We're seeing the need for 30 and 60 watt systems in ITS applications. We're seeing a lot of high-end security devices that are created that have the need for higher power. There are cameras now that come in their own enclosures that have heaters in them. They have wipers for screens. They have, of course, their pan tilt zoom. They really take it up a notch. The application drivers in security and surveillance. This is the fastest growing application for industrial Ethernet products. We see more and more Ethernet devices being used. More and more PoE being deployed. IP cameras are required. This is a major part of the emerging smart city networks that we see going in around the country. And IP cameras are becoming a lot more intelligent. They're allowing a whole host of analytics at the edge of the network. We've got, the decentralized intelligence leads to automated decision making. And we even have sensors. You've got sensors that are controlling the cameras and cameras that are triggering different alarms. So everything is being tied in together, and it's all riding on a backbone of Power over Ethernet. Finally, intelligent transportation systems, or ITS. Where are we seeing this? We're seeing the PDs, traffic control systems. We're seeing, again, a lot more cameras. We're also seeing radar systems and wireless access points, and even point-to-point radios in many of these systems. The application drivers. This is the foundation for the smart city or the smart corridor that we see going through. There's a priority for many local governments to deploy intelligent transportation systems, because this is just going to improve efficiency. As more and more vehicles get on the road, as populations increase, they need to have more efficiency. And what this does is gives rise to automated decision making at the edge of the network. The edge of that network is sign and traffic light control. We see it a lot more intersections that are deploying intelligent transportation systems for traffic control. So now turning to the managed functions that we wanted to discuss. Taking an overview look at it, these are what separate an unmanaged PoE switch from a managed PoE switch when it comes to the Power over Ethernet portion. You've got PoE configuration, and this allows a breakdown by port configuration of all your PoE functions. PoE scheduling, that allows the PoE power to be scheduled by port on a very granular level. And this can become very important for cost savings. If there's a location, a plant that, let's say, is only running one shift and they have a number of PoE devices, well, you're not going to want to have those devices active and powered on while nothing is running in the plant. So this gives you the ability, instead of shutting systems down, it gives you the ability to shut power off to the devices when they're not in use. So it gives you an increased, less power consumption, gives you increased savings in that regard. Then finally, the PoE Watchdog. How many times do devices lock up? If they've been running for a considerable amount of time, they may get locked up. They may have a change in power that causes something to lock up. And what happens if this is in a critical area? Well, first of all, you may not know that that you have that problem, and secondly, you want to be able to resolve and remedy that problem automatically. Well, PoE Watchdog gives you that capability. So if we look a little bit deeper on PoE configuration, the top part of the page would give you an overall view of your PoE system. This is going to let you know what your supply voltage is, what your total power consumption is for all your devices, and it's also going to let you know what your PoE budget. That's a key item to keep track of in any system, is your actual PoE budget. It gives you the ability on a port-by-port basis to enable or disable PoE, or actually enable, disable, or scheduling, and that ties into the scheduling function that we'll take a look at. It also allows you to configure the maximum power by port that's allowed on that port. You can also set the priority of a port, so in the event of power requirements exceeding your system power budget, you can make sure that your devices, you ensure that only the devices that are the highest priority will remain active in that system. Additionally, you've got the capability to trigger alarms if there is PoE power is halted to the device, as well as you've got a number of diagnostic capability, basic diagnostics. It displays the operating status of the port, as well as the monitoring data for the devices. And when we get to the demo, we'll see some live data on that. So if we take a look at this, what happened very quickly there was a power event, and we had priority 1 set on that top camera, and that camera kept running even though there was a power event. What happened was there was a bit of a sag, so priority 2 and priority 3, the access point and that dome camera, they were cut off automatically, leaving only the most important device in the network running, continuing to run. So we can see that again. So it gives you the capability to select which devices are going to run and not run. Looking at PoE scheduling, as I said before, this gives you a very granular capability on each individual port. So you've got capabilities such as select all, so you could set them all at one time. So you wouldn't have to go through and select each one individually. But what you can do is you select the port that you want to schedule, and then you go through and you set your times that you want it on and off, and it gives you that capability. So in order to use scheduling, that's why we have the note in there from the PoE configuration page, where I said you could enable, disable, or schedule. You would want it to be set to scheduling if you're going to be using the scheduling. A key thing to note here on the scheduling is that the scheduling is all available via SNMP. So if you were using a MIB browser in the network and you wanted to utilize SNMP, you wouldn't even have to go into the web pages of the device. You could schedule your ports using SNMP. So now if we take a look at just a little animation, we've got the camera is off at 6 o'clock. It turns on and runs till 12. And then it shuts off again automatically. This you could set up for day in and day out operation for any number of hours that you wanted to set up on your network. So finally, looking at PoE Watchdog, and as I said earlier, this is my favorite functionality on this, because what it does is it gives you so much capability in monitoring your devices and also remedying any lockups or anything on that on the device. So of course you've got to enable it on each port. Then you enter the IP address of the PD. This would be an address of any access point, camera, anything that is being powered over Ethernet by the switch. Additionally, then you enter the ping interval, and all this is using is ping to monitor and communicate with the device. As you know, utilizing ping requests and getting responses is a basic way of knowing that a device is active or still available on the network. It's configurable in the number of seconds between each ping. And then you've got the capability to enter the number of failed pings. You may not want to have it register an error if it misses one ping. So you've got the capability, the failure count is from 1 to 10 that you can utilize. Then on the right-hand side of the screen, you select the action that's going to happen if all that criteria is met. You may want to power cycle the device, or in some instances, you may want to just power off the device if it's not responding. Additionally, what you can do is you can have an SNMP trap, or an unsolicited message from the switch can be enabled to send a message to a monitoring station that there's been an issue. So additionally, you can configure the delay in the number of seconds to wait before the switch pings the PD after a power cycle. This is very important because you could get yourself inadvertently locked into a cycle of the watchdog just continually cycling power to the device. If you had if you didn't have a delay at startup on the device, because what could happen is it could start pinging the device right away before the device had actually been had rebooted fully, and it would not be responding. So if we take a look at the PoE Watchdog in action, what's happening is those pings are going out over the cable to the device, and all of a sudden the camera is not responding. It meets the set criteria. And what happens is, in this case, we've decided to turn the switch off, decided to turn the camera off, excuse me. And, but we've got the opportunity, we would have the opportunity to cycle power to the camera. So those are the three items. Now what I want to do is turn to a bit of a PoE demo. Before I change my screen over, this is what we'd be working with that I cobbled together. You see at the top there, this is a setup that I've got at home. I've put together a few old PoE cameras, and we'll see when we get to the web pages just how little power they use. On the left-hand side, we do have a managed PoE switch. It is 4 PoE ports. And then that little device on the right, to the right of the switch, is an Ethernet cable breakout board. And what this does is it gives us the capability to do one outbound connection from the switch, and then a connection from that board to one of the cameras. And actually, it's the camera in the middle that we're utilizing today. And what that does is it gives us a breakout of all 8 conductors. So what we'll be doing today is we will be breaking conductor 3, which is one of the receive conductors in a 100 megabit 100 megabit Ethernet connection. So right now I'm going to switch over, and you can see this is our this is the switch that we have active, and we're going to log in. And this is where we would have all of our PoE activities. So we've got the PoE configuration. And so this is the same as the screen we were looking at before, but this is with active information. You can see that 3 of the ports are delivering power, while port 4, registers it as searching. This is just a connection back into the rest of the network. We can see that these are PD class 0. These are old, as I said, these are older devices. They're low powered devices. And we can see that the consumption right now is very minimal. Oddly enough, the older device, a D-Link camera, is actually consuming the most wattage in the setup. We can see that our supply voltage into the device is around 55.5 volts. Our total power consumption is 9 watts of a total 120 watt capability. And the system power budget is also adjustable in this regard. Just looking at the PoE scheduling, as I said, this gives you the capability on each port to set. So what you could do is you could select all on that. You could delete all. So if you've made a number of entries and you don't like where it's going, you can delete everything out of there. You don't have to go in and take out the entries individually. So in this case, you may want to go in and select times where it's going to run. And as I said before, I forgot to show you that. Under the PoE configuration, I know in the slide I had it listed as enable or disable, but you can also, of course, select scheduling in there as well. So in looking at the PoE Watchdog, under PoE Watchdog, you can, as I said, enable or disable it for each port, individual port. You put in the PD IP address. In this case, the cameras are addressed 20, 21, and 22, and the IP address we're looking at is 21. That's coming out of port 1 on the switch. We've set it up with a ping interval of every 10 seconds, and we've set it a failure count of 1. Now, of course, action if no response, we want to power cycle it. We've kept the default on there, and we can also manually reset the power on any device. So what I could do is I could hit reset on this, and it would manually reset the device. So if they hadn't received a warning, but they thought something might be amiss, they could always force a reset and not wait for the watchdog to do that. So we can see here is camera 21. We've got a live setup on it. You can see that we can move it. We can see there's the D-Link camera that's sitting next to it. Over here, we've got the other Amcrest camera. You can see your humble host there, but this is the other camera. And we'll go back to the garage view. And what we're going to do now is I'm going to step over here, and using the trusty paper clip that everybody needs in their arsenal, I am now I've just taken out line 3 in that connection, because what we want to do is we still want the switch to be seeing those messages going out. And what we'll have is, oh, I believe it just rebooted it. Yep. So you can see I have no capability on it right now. It's rebooted the device. It said, okay, I'm not receiving the pings back, because what I did was I killed the receive side of it on that device, that breakout board. So now what it's done, and it's circling, but it's not active. So now it's done its reboot. And now it's back into, okay. Now it will be going back into active mode, maybe taking a little while to reboot. But at the same time, if we went back to the PoE configuration page, we would have seen that it was that the status was searching. We would have seen that it did not have any power. What we can do is, oops, wrong one. If we go and we force a reset on I don't know if you could hear that. It just made an audible sound. So now we've forced a reset on port 2. And if we went back to the configuration page, it's oh, okay, we must have been off too long. And it's not up to full power yet. So that is managed PoE functions in a nutshell. And this camera, oh, it would help if I reset line 3 so that it's active. That's why it keeps resetting. There we go. So now everything is active again. So in closing, I'd like to open it up for any questions. And of course, at any time, if you have questions about Ethernet switches, Ethernet in general, or power over Ethernet specifically, you can always hit me up on email, kaustin@phoenixcontact.com.
Hey, Ken, I don't think the text Q&A was working, so you may have to go and look for Audible.
Okay. Let's see, how can I?
The lines, I think, are open if someone wishes to speak.
I'm going to stop sharing, or I shouldn't stop sharing. And we can leave it open.
Maybe just a reminder that this will be posted and available for those who registered. If there's anything that they missed, and they can contact you with any questions.
That's right. That's why I put that kaustin@phoenixcontact.com up there. If there are no questions, Dan, are you getting anything in text?
No, sir.
No, sir.
I think go ahead and wrap it up. I'm not sure that there is an unmutability at the moment. Okay.
All right, folks, then if you do have any questions, please do throw them in an email. Hit me up at kaustin@phoenixcontact.com, and I will certainly get back to you on every single question that you've got on the session today. I appreciate you attending. Hope to talk to you soon. See you again. And everybody, have a great rest of your day. Thank you. Thanks, Dan.